Hello everyone. I'm going to demonstrate my work on the project 1 for CS643 cloud computing. So the basically the functionality of the project is we are going to come up with two microservices. So the first microservice basically runs on a EC2 instance, which fetches the images from an S3 bucket and filters the images which has car in it. And then the second microservice picks up those images which has a car in it, and then figures out if that image also has some text. If it has a text, then it will write it into a file, the image name and then the corresponding text. So basically for the car and text recognition, we will be using this AWS recognition module. So I'm going to start the AWS lab. So access the AWS Academy Learner Lab and start it. So while starting, let me extract the project. Okay. So there are, as you can see, there are three folders: AWS setup, and this has all the source code for car and text recognition, and this has all the scripts. Okay, these are not required, and this contains all the scripts that is required for setting up the AWS resources, building the source code, and deploying it into the EC2 instances. Yeah, so this is also required. So this readme.md has all the required instructions, which I'm going to explain. Basically, you need to have I'm sorry about that. Basically, you need to have AWS CLI installed, and then OpenSSH for Windows. So I'm going to be using, I have Git Bash installed, so I'm just going to be using that. And then the Java 7 plus, 17 plus. So I have Java 21.0.7. So, and then Maven. So I have Maven installed, and I already installed AWS as well. Yeah. So all the prerequisites are already there. So okay, so the AWS lab started. So let's access the console. Just wanted to show you there is no running instances. As you can see, these are the instances. This is probably the instance which I tested. It is already terminated. Okay, so there is no running instances, and if we go to the queue, there is no queue. So we are going to create everything from the scratch. So this is basically a a clean environment, AWS environment. So if you want to create a manual launch instance, create a EC2 instance, we need to choose a key pair. As you can see here, we need to choose a key pair. So we will be using the same key pair in our script as well. So I'm just saying, so how to access the key pair. So in the EC2 If you go to EC2 and then click on the keypad, so you have there's an already pre-created keypad. So we will be using this in our setup, so we need this name. Okay. So yeah, let's first configure the AWS. I'm running this currently in Windows, but if you are, so you can see that all these scripts has both the PowerShell and the shell script versions. So if you are running in Windows, use PowerShell, and if you are running in Linux or Mac, you can use the shell version of this. And if you are running in Windows 11, so that's another thing. So you might encounter an issue that you might not be able to run the PowerShell scripts. So it is because by default the execution policy is set to restricted. So you have to use this command, set execution policy, to set it unrestricted, which you can later, after after running this test, you can set it back to restricted. Okay. So to configure the AWS credentials, let me open the PowerShell first. Okay. So let's configure. So we need to configure the AWS credentials, CLA credential, the credentials which the CLA is going to use. So this will display all the credentials which I should use for this particular session. So you can even copy the whole thing into your credentials file, but this path won't be there, so you may have to go into in Windows, you may have to go under users, AWS credentials. Okay, so you just need to replace this content, but I'm just going to continue using the CLI. Okay, you can use this if you are running it for the first time, this would be none, and then you can just copy this here. Okay, so I'm not seeing, and then we have to download the PEM file, which we need to use it to access the EC2 instances once they are created. So download it. Okay, and then sorry about that. Just copy this into your AWS setup folder. Okay, so now we have everything here, and AWS is configured. AWS CLA is configured. So let's go back to the README. Yeah, so basically this explains all this, how we can set all the information. And now we need to run this first script, which is AWS setup. So for AWS setup, you need the IP address, your IP address, and the key pair name. So basically why we need this IP address, so that when it creates a EC2 instance, it automatically creates, the script will automatically create the rules so that only your IP address is allowed to access the EC2 instances. So that's why you need your IP address. So I'm just going to use Google. So you can access this site. So this will give you your, provide you your public IP address. So I will just choose my, copy it and paste it here. Okay. Okay. The first one is IP address, and the second one is the name of the key pair. So it's VOC key. So yeah, there is another thing. So Windows will always prompt you to run whether you want to run this or not. You have to say yes. So I'm just going to say run. So first it is going to create a security group, and then the queue, and it is launching the EC2 instances. Yeah, so sometimes when it tries to get the this happens only in shell script, PowerShell, but this doesn't happen in shell script. So let me copy this information because you may need it. Okay, yeah, at least this one you won't need it. All these things you can ignore. Okay, so we need the public IP address because later we need to connect to those instances. So you can just go to your console, and then so now so the EC2 instances are created and it is running. So just copy this public IPv4 address. Yeah, you can either copy from here or just click here and then copy it to your notepad. Okay, choose the next. Choose the next one. Click here. Okay, so the public IP addresses are done. So now we have. I can also show you. Now we have the queue also created. So you can see the queue and all the rules required for this. So everything is created. How can I show whether the rules are created? So you can see the security group is created, and as you can see, it just allows only the SSH from my IP address. Okay, so that is cool. Let me close this. Okay, so the next step is, okay, so we need to update this configuration. So in the AWS setup folder, I have added a configuration file. So open it. So basically I don't need to change anything because this is exactly the same queue the script generated. Right, this is exactly the same queue. Yeah, but you may have to change this to your queue URL, which is printed at the end of this. So you can see it prints your queue URL here, and yeah, you can change the output file name to whatever you want. Yeah. So once you have updated your configuration, so the next step is to build the source code. So let's build the source code. So for build, just run ps with config.json. Yes. So this will build the source code, and using the POM file it will download all the required dependencies, and then it will also generate a run.sh file. Okay, so now you can see that these following folders are created here. So you can see that, so it created the jar and a run.sh file, right? So now we have completed the build step. So now next step is we have to do the deployment. Okay, so before you do the deployment, yeah, let me see so when you are running the when you used the lab users.perm, so usually during my first run it showed that it is too open, so it should be restricted. So I have restricted it using these commands to my current user. So you may have to do the same in Windows. I will add this to the readme file later. If you are in Linux or in Mac, then you have to use chmod 400. Change the to modify the access of this particular file in your folder, so that SSH won't show any error. Okay, so the next command is, okay, let's run the deploy. So the deploy script can deploy as well as run, but I strongly suggest don't run it, just do the deploy. So you can, as you can see, the sample there is a deploy only, because the script will just sequentially execute it. But if you want to first run the car recognition and then run the text recognition, then it is better you first just deploy and then manually connect to the EC2 instances, and then run it. So I'm just going to do the deploy only. And okay, the first one would be the EC2 instance where the car recognition will run, and the second one will be the EC2 instance where the next microservice will run. So I'm going to just say deploy only. So basically this connects to the EC2 instance and then copies all the libraries, basically jar file and the run file, and then set the proper permission for the run script. And yes, again, if the EC2 instance doesn't have Java, this script will automatically install Java as well. So okay, see, this is what I was telling. So this lab user.perm is too open. Okay, so yeah, I think this is a new file, so it just basically asked me to do it again. Okay, this is done. Let's run the deploy again. So now it figured out that Java is not there, so it's trying to install Java. Okay, another thing which is I'm just using the same credentials, AWS credentials, which I am using to connect to EC2 instance, for the EC2 instances to connect to the queue. Okay, so deployment only mode, deployment complete. Okay, now I have two windows of for this. Bash. Okay. Okay, so I'm going to connect to the first. I'm going to start the text recognition, so which basically listens to the queue, SQSQ. So yeah, so this one is the text. Yes, this is the text one. Okay, as you can see, it has the text recognition, so I can just run. I can just run this. Okay, so basically it is waiting for the messages, and if I want to exit, I can just simply type exit, so it will shut down. But let me run it again. So it's going to wait for the messages in the queue. Okay, this is done. And here, the next one, I'm going to connect to the EC2 instance where we have deployed the text one. Okay, so this here you can see you have a car recognition. So this is going to download the S3 files, download the image files from S3, and then checks if the car is there. If the car is there, then okay, let me push it into the queue. And once it is pushed into the queue, then I mean basically it pushes only the name of the file, and then this will pick up the name of the file and then downloads the file and checks if there is any text in that. If it is there, then it writes it to the file. So let's run it. So as you can see, it just pushes it and then it detects text, not detect text. Okay, so it has processed all the files, and here also there is no more messages, that's why there is no log running. So let me exit. Okay, shutting down. Now if I see ls-t, so you can see the text underscore output is there. So if I open it, it gives me all the all the images which has car as well as the text. So so this is what I have implemented, and I believe this is what is expected from this project. And next step after everything is, so I have added many other I mean, okay, before I go into the next step, next explanation about how I have used the how I used AI for this project, let us, so the demo of this application is complete, so I'm going to clear up the resources which I used in AWS. So for cleanup, there is another script which I have added, which is basically cleanup. Cleanup.ps1. So if when you run this, it will just basically destroy everything which you created. Basically the queues, the security groups, the EC2 instances, everything will be cleaned up, and the AWS instance will become as a clean AWS instance for the if I want to run it again. Yes, please. So it's basically terminating the instances. Usually this is some kind little bit of time consuming process, so please bear with me. I forget to mention that, so when you move from the AWS infra setup to the build, I think you can just simply do the build, but before you do the deployment, make sure the EC2 instances are in running state. Okay, so you can see this page is not refreshed, that's why you are still seeing the EC2 instances. Let me refresh it. So here you can see it just terminated the instances and then deleted the queue, security groups, etc, etc. So if I refresh it, there won't be anything. Yeah, there's nothing. So let me remove this filter. You'll see the EC2 instances. Now you can see the ID here. Those are in terminated status. So okay, let me end the lab as well. Yeah, okay, so that completed the demo part. So I just wanted to explain how much I have used AI. So for the coding part, for this Java code, mostly it just gave me some sample codes, just a single page sample code for how to access S3 image and how to use recognition and etc, etc. And then I just developed it using OOPS principles. So I defined services and then defined everything as a component. So you can see S3 is a separate component, SQS is a separate component, and recognition service is a separate component. And then used everything in the image processor.java file. Let me open it in Visual Studio Code so that I can explain. Okay, so I have used everything here. The idea was to implement everything as an interface, a separate component, so that I initially thought I can do unit testing, but eventually I didn't do any unit testing. So I could have just simply gone with a single file approach, but yeah, this is this looks neat, clean, because the app is basically just initializing all these things and then invoking just run function and then finally cleaning it up. So similarly for the text recognition also, I got some boilerplate sample codes and then used a similar pattern and created all these things. The big part where I used AI is here, coming up with this shell, and basically I initially came up with this shell script. So this basically I used Copilot, GitHub Copilot, as you can see. I don't know, in this machine I might have not configured it properly, but yes, I used GitHub Copilot. Underlying model was automatically selected by it. Most probably it uses GPT, some version of GPT. I'm not exactly sure. yeah, I'm not exactly sure which model it uses, but mostly GPT. And yeah, so yeah, I was about to say this whole AWS setup script and build script, which does all the build and creation of the run file and all the cleanup scripts. All these things I just used Copilot to come up with this complete script. So initially I created the shell script using Copilot. It's not a it is not it didn't work like in the first time itself. It took multiple iterations to come up with a better version. And yeah, multiple iterations to come up with a better version. So once the shell script version of all the scripts were ready, so and I have tested it, and then I come up with this and then I asked Copilot to generate the corresponding PowerShell script version, because I don't know whether the professor will use the Windows machine or the Linux or Mac to run this script, run these scripts. So I have not added. So this README has basically, this is a very simple. If we can run this script, it is a very simple setup. But if we want to do it manually, I will add one more readme.file where it will explain all the steps to do it manually without using the scripts. It would be a little overwhelming for individual users, so that's why I came up with the scripts. So to answer the question whether AI agents are useful, yes, it is extremely useful. It is not just here. I use it a lot in my work as well. So in my work, we have access for both Claude Code and GitHub Copilot. So we nowadays we use Claude Code a lot, because because when we started working on this GitHub Copilot, using this GitHub Code, it was not working on an agent mode. I think the recent version which I used in this project automatically is running in agent mode, so which is really cool. Claude Code has the powerful models. Like I'm still not using Opus, even though I have access to Opus, but our code base is more. So if I use Opus, it would just simply exhaust all the tokens I have. So we have a limit for per day. So it is really helpful. It helps in coming up with a very quick solution and some boilerplate code. And the most hated part in using in development is creating the unit test, and AI takes care of it now. So but will it work or not? Yes, you have to spend some times to perfect it, like I did here. Sometimes it cannot it might just invoke a private function, which is not possible to invoke. So those kind of mistakes it does, but still it the time it takes to complete the coding is fast. And then the experienced developers can simply review it and then fix the edge cases and the issues. So yes, the AI agents are really helpful. It increases your productivity. I spend majority of the time perfecting the source code, but even though the heavy lifting is done by the scripts, the heavy lifting is completely taken care. I mean, I spend only maybe like 3-4 hours to perfect these scripts. So yes, it really adds values. Okay, that concludes the demonstration. Thank you so much for listening. I might be very boring to listen, but yeah, I hope I explained things clearly. Thanks for watching.